Let's imagine we have the same vector field of the previous problem, A equals Y I hat, I think. And let's draw that again. So it only has an X component. And so if this is the X direction, this is the Y direction, for some value of Y, when Y is 0, we get 0. So we have nothing along here. But as we move slightly above here, we have some positive Y value, like Y equals 1 or something. And so all along here, we have a vector field where the arrows are pointing to the right. And the further up we go, the greater the component is. And so we'll do something like that as we go up. And when we go below, it becomes negative, right? The Y value is negative. And so we'll just flip the direction of the arrows. Something like that. And we saw that the curl of this vector field is not equal to 0. And this was because we have a derivative of the X component of A with respect to Y, which is not equal to 0. In fact, it's just 1, right? It's dy by dy, that's 1. And then we have k hat when we're doing the curl of A. So this has a curl of the curl of A is proportional to the k hat unit vector. And so it's a vector that points upward. Let's ask the question, can A be an electric field? Right? Can we put charge? Can we distribute charge in space such as to produce this kind of electric field? Well, we know what kind of charge distribution is associated with an electric field because all we have to do is take the divergence of the vector field, and that will give us that'll be proportional, right? The differential version of Gauss's law, that'll be proportional to the charge density. In other words, we're thinking of divergence of the electric field is equal to the charge density over epsilon naught. So we can find out if there's any charge. The divergence is just, right, in x, y, z coordinates, is the x component with respect to x plus, right, the scalar dy, day with respect to y plus daz with respect to z. And we see that the only component is x, and it doesn't depend on x because it depends on y, and so this has to be 0. And so if we think of it as an electric field, then what it means is that the charge density is 0 everywhere in space. So we're not creating this by putting charge in space.